Alright, so this is my final project for TE 809 by Josh Springer. So this is a kind of a curriculum proposal for Lab Aids middle school science program, and I'm going to be using ed reports as well as the textbook for this class by McGee and Willis to kind of help solidify some of the information that we will be going over. So this is, my audience would be school administration. That's who I would propose any budget spending or something with them. They'd have to kind of get it for me. The step-up, I did a little bit of research on the website, and this seems to be a parent company, or not a parent company, a co-company with Lab Aids that kind of does a lot of the research with Lab Aids to kind of help develop the curriculum. The issues in science is the middle school curriculum that they used, and this earned the second highest overall scores of any published middle school science curriculum. This is from Lab Aids and it's on their websites, and this is designed for NGSS, which is the next generation science standards, and as well as designed for middle school. So the next generation science standards, those are the new science standards that education is kind of, or science education is using now. So it's the latest and greatest kind of thing there. So the instructional material incorporate and integrate the dimensions and incorporate three-dimensional objectives and find three-dimensional assessments for and of student learning. So this is using these three dimensions of the next generation science standards, using phenomena to kind of guide this, and using this they use these three ideas to kind of help implement their lessons, and this is kind of what they use to design them. This is what NGSS kind of is. Materials that they use, so this includes physical, life, and earth and space science, which are kind of the three main informational sciences, as well as engineering, technology, and the applications of science, which is kind of how scientists look at the world and kind of maybe these things, how they apply to engineering, how we get cell phones, how we get computers. One example that they give was when they were looking at chemical reactions, they give the example of hand warmers and how that is a chemical reaction releasing heat. So that would be some applications of science or engineering and technology, and for kids to get hands-on with science. So some other things on Lab Aids on their website. So student and teacher materials are developed using an iterative process which involves development, piloting, and field testing phases. So this is basically a three-step process: developing that curriculum, kind of guiding it, seeing where they want to go, and then eventually field testing it and then getting results on it. And then what they do is that they look at the piloting and field testing phases and collect data on it and analyze it and say, okay, is this the best way to teach the kids, or is this way a little bit better? And maybe they'll compare different experiments. So that's where you kind of get that research-based curriculum. And if you look on their website, that's one of the big things that comes up is research-based curriculum, because this is based on tests. All right, and it's based on things that they have done. The units are guided by phenomena and are structured to integrate problem solving in its labs and investigations. So like they'll look at what is rain, how do rocks form, and just these different ideas is what they kind of use. And they have these units which they kind of go through some some problems and some ideas that the kids will eventually answer as the unit goes on, and it has how long that'll take, as well as the different standards that it'll hit. Like if you go to the website, they kind of have like a sample curriculum of a unit, and it kind of goes through, okay, this is where we hit this standard, this is where we hit that standard, this is how it goes with other materials, and this is kind of how they implement their information. So some reflection on my classroom and teaching situation. This curriculum will really help with my organizing curriculum into a certain way that makes sense for students. This also lines up well with the standards that they have. So this would be a way to make sure that they cover all the bases because the standards are already included. Phenomena and problem-based learning are used to kind of engage students and really engage students with that dopamine. I know that the book that we talked about uses dopamine to kind of help trigger that learning process, to help them remember things better and really apply it to their real world. So what changes would be made? My PowerPoints and notes would have to be restructured, so just in a different way. And I would also have to lean heavily on the labs and the order in which the information is presented, because the unit kind of ties in the labs, it ties in the activities all together to create kind of a coherent storyline which the kids can follow. So it really couldn't, this random video that I thought was funny, I'd have to kind of plan it ahead of time to kind of just kind of incorporate it with material instead of just throwing it on, so it'll make a little bit more sense to the kids. And the students may just have to have a mental readjustment, just a way to get them kind of adjusted to the things that they're learning. On page 104, an upgrade to your teaching points out that students summarizing enhances their understanding of academic content. So like if they will basically, like what the curriculum would do is that they would kind of have to summarize the information that they learned, which will really help them understanding better. And during the chapter over brain-friendly assessment practices, there's a discussion of using rubrics and other tricks for understanding to truly assess students' understanding. So like this curriculum uses rubrics and other ways to kind of assess student learning, and there's multiple checks for them to learn for this to be checked. In the chapter Goals, the Drivers of Everything, explanations are made about how curriculum should be written backwards from the goals and standards to the classroom. So basically, backwards by design. So basically, you look at the goals and then you go backwards from it, designing that way. And that's how this curriculum was designed. It was looking at the standards, it was looking at what kids need to know, and then building it out that way. All right, in the chapter Creating a Brain-Friendly Classroom Climate, it highlights how the curriculum should be engaging and make the kids feel comfortable, just creating that environment that's fun and engaging to learn, which I think this curriculum will do. It looks like it really has a lot of engaging hands-on activities for kids to utilize and understand the information better. And during the chapter Teaching towards AMT acquisition, meaning making and transfer, it outlines several steps that students need to be done for students to learn most effectively. I know when some of the units that they kind of talked about is they have to, there's a few terminology that they'll throw out that the kids kind of have to know to understand and make meaning of the rest of the information, and then eventually transfer it. So maybe this might be the engineering project at the end of a unit where they really apply this information learned to a new project where they can really showcase what they've learned. So here are my sources. Thanks for the class. Learned a lot. Thank you.